Yeah, so thank you, first of all, for the invitation here. We're very happy to be here. And it's me and Peter here, who come from Aarhus University, but not from an engineering department. We are anthropologists. And what we are going to talk about is not the technical aspects of robots, but something that we consider important from our point of view, and something that we think may be lacking in some design phases as it is now, namely the focus on the humans in the system. And our main point here will be that humans are always in the system. You can't leave them out of technical solutions. So why not make that part of the design process? And one thing I want to say to you here in the beginning is we know that when you finish, you will create technological systems of many kinds. But are you also considering that you are creating the future environments, not just for yourself, your families, your children, if you get those, but from a lot of people who will have to live close to your inventions. And what does that mean? And the other part of that coin is that the people who are going to live with the technologies you create are not just living with them, complying with them the way you thought they would. They are doing things to them. They are tinkering and recreating them in their own environments. And all of that could be part of the design process, because as it is now, a lot of autonomous systems that have been checked and rechecked in the laboratory or in simulations fail when they actually come out to the real life where people are. And humans are always part of these failures, but they're also part of what upholds the robotic system. They help the robots that are in their environments. That's what we have seen in our work. And just very briefly, what we do is that we observe robots in the wild. So we go out in a number of workplaces to see how robots are actually working. And maybe you will say something about that, Peter.
Yes. So our methodology was, as you can see up here, we observed robots in the wild. So instead of doing it in the lab or doing a lot of simulations, we went out to companies using robots and how they were used, and had qualitative interviews with the people working there, walking around close with these robots. And we compared all of these external field sites that we found, and we'll show you a picture later of a gathering of all of them. And we compared them to our internal field sites, where we had these 4 use cases, which we have heard from all 4 of them today, I think. And then we're using this sort of ethnography, which will allow us to observe different things that are not necessarily visible if you just look in the logs of the robots or in simulations or in KPIs for that matter. Yeah.
So apart from looking at these robots who are already employed in people's everyday lives, and we'll come back to where, we also follow the process of designing in the RoboSAPIENS system. And no matter what case we have been studying, even the cases when RoboSAPIENS began, we were told that in the Gunnerus, for instance, we wouldn't be needed because there wouldn't be any people involved. But of course, that was not really true. There were people involved everywhere. Even when we think that the systems we have created are completely autonomous. And we have done field work now, apart from the use cases in RoboSAPIENS. Actually, by now it's more than 14 external field sites. And maybe you briefly can say which.
Yes. So as you can see up here, we have been to both industrial sites, we've been to companies dealing with refurbishment, we've been to hospitals, offices, warehouses, we have looked at restaurants, we have looked at very different kinds of robots, with cobots, humanoid robots, AGVs, and we've also looked at industrial robots. So basically all kinds of robots that we could find and that are related to the project.
And the reason we have done that is to actually see a variation. And when we have found this extreme variation in sites and types of robots, we have looked for what are there in terms of patterns that we can analyze goes across. And one pattern we have seen across all these cases is that when we see the same robots that we're presented with in these real-life settings in media or at robot conferences, they do not look like they do in real-life functioning. They are much more well-functioning. They never break down. They never need human help. They are a completely different type of machines, you could say, from what we actually see in real-life settings. You can supplement that?
Yes. So basically, at conferences, the conferences we've been to, robots are sort of sold as being more autonomous than they actually are, which in turn creates the sort of expectation, which we'll also talk about later, about this full autonomy and adaptability of robots, both from more sort of general public, but also inside the field of robotics. And the reason for this is also that the robots we see at these conferences are the demos they are making are very controlled demos. And sometimes they're not even related to what the company and the robots they're selling are actually supposed to be doing. They're just sort of a way to get people over to their stand. So the robots getting sold at these conferences are not really the robots that are being used in real life as well. And what we're also seeing is that the autonomy that is sold at these conferences often only work because humans are there to stabilize it in some way.
Yeah,
Yeah, sure. And we have some examples of this, what we call collaborative autonomy, where we were at a restaurant and a waiter dropped a glass. And this restaurant, they had two robot waiters that would help deliver food. And usually these robots are supposed to stop if anything is in front of them, so that they don't hit customers or drive over glass. But in this instance, what happens, the robot were driving towards the glass and the waiters managed to quickly see it and had to press stop on the robot before it hit the glass. They then had to guide the robot around the glass and towards the station where it's waiting for the next delivery of food. And then while they were sweeping up the rest of the glass, the second robot came and just drove completely through all of the glass and started spreading it all over the floor. So again, they had to stop it. And it's this sort of way where the robot waiters don't really work without the human waiters there to assist them. And the second example we have is at a company that has a production department where, because of the more dynamic workflow that they have, instead of having a conveyor belt through the entire factory, they have this big factory floor where they have 12 workstations, and then they have about 10 AGVs driving around between the stations and to a final conveyor belt to deliver various products. And when we were there, what happened was one of these AGVs, for some reason, stopped about 1.5 meters before the actual drop-off point, which then led to a whole queue of AGVs just standing in line, not really being able to deliver, and of course, to slow down production in the factory. And what was needed was one of the workers had to go over and just reset the robot and just pull it back a little bit and then start it again, and then it could deliver. So it wasn't even that difficult of a fix, but it sort of shows again the sort of collaborative autonomy that is needed in these systems.
And this is something that we see across all cases. We have never seen an autonomous robot in our studies. We have never seen a robot that could do without the humans around them. But that's not the story that we are normally told. So we think that it's interesting to take this into account when we also work with our partners in RoboSAPIENS to look at what we found were the transversal main analytical categories we found in all the cases: safety, trust, anomalies, sabotage, and sim to real. And in all of these, as I said, humans were involved. And one of the examples is that that humans are often not applying the standards or the rule following that the people who have created the technology think they should be working from. In fact, it was across all the cases, again, that humans were not following rules. They were trying to make the robots adapt to their conditions, to what they think the work was about. So standards for safety are everywhere, but also that humans break these standards or play with them.
And the specific example we have here is if you look at the bottom picture over here, we have a conveyor belt, and it was a specific company that did refurbishment. And this conveyor belt got filled with a bunch of different electronics, which got lifted up by this robot onto the conveyor belt. And this could weigh between 200, 300 kilos of electric waste that employees then had to rifle through to see what's worth saving and refurbishing. The issue that happened here is that right on the other side of this little yellow fence, there was a very clear warning saying that you should not put your hands anywhere near this conveyor belt or the start of it, because there's a risk of falling, electronic waste. What we observed, however, is that every single time they unloaded any sort of container or anything onto this conveyor belt, they always had their hands over there, already rifling through it immediately and completely ignoring this very, important safety feature that was implemented at this company.
Yeah. So humans are not just a nuisance in the system. The reason why they had a reason for doing so, it made their work life more easy. But the people who made the robots had not inquired about what would make their work life more easy. So it was a sort of workaround in the situation. Trust is another recurring theme, and we would say that that's also something that cannot be built into a technological system. It's something that comes in the dynamic between humans and machines. And it's often also connected to this mismatch between people's expectations of robots as much more autonomous than they really are, and then the reality they meet. And that can create even dangerous situations in our field work.
And here we again go back to these conferences a little bit, because there is this trust in robots. And when you have too much trust in what a robot can do, it can lead to a perceived underperformance of what the robot can actually do in practice. And we talked to specific companies selling robots to other companies, and they have this quote about how, or the first thing they have to do whenever they're selling anything, where they say, it will never happen, it just can't. It becomes too complicated. So we have this kind of 80-20 rule where we're trying to get the customer to scale it back. And this is because they have to scale back the customer's expectation. And about 80% of what the customers expect, they can't live up to these robots. And that's sort of this issue that comes with this trust. And this is people, even the people who are trusting it, even people in robotics. It's not just a general public. So it's everyone that has this very large trust of the robots.
Yeah. And the last recurring theme that we found across all the cases is that humans are not just taking the technology for granted. They are always trying to test it. When they get a new technology, they are what we call tinkering with it. It can be out of malice. It can be because they want to sabotage a system they don't like because they think the robot has taken over their work. But very often it's just simply curiosity. What will happen if I put my hand through this fence that the manager has said I should not put my hand through? What would happen? Would it be something I could use in my work, or is it something that will disrupt something? And humans do that all the time. Both people who are accustomed to robots, but also newcomers. And over time, what they do through this kind of tinkering process is they learn the boundaries between themselves and their expectations and what the robot is doing. And that can lead to a local optimization of how they actually work together. So tinkering is part of the process of implementing robots. And we already heard about the safety things, so I think I will skip that now. And that also goes for what the robot may think of as anomalies, because very often we have seen in our fieldwork that humans are doing things to robots that robots will think of as negative anomalies, as something that the robot should react to in a negative way, so to speak, or remedy this effect of the human intervention. But what it is, in fact, often is humans trying to help the robot. And if the system doesn't allow for that, then a lot of problems go unsolved. So this kind of both tinkering and helping the robot are part of the systems. They are not something out of the systems. It's not an exception. It's something that goes on a daily basis. We've heard also in RoboSAPIENS about sim-to-real, and often we see that you do try to put in humans in the simulated systems, but it's not the humans we know from our work. It's more like off-the-shelf humans, off-the-shelf simulated humans that are used almost as a table and a chair, but they move. So that's what defines a human here. But they are not noise in what we see. They could be in the system in a more rewarding way, you could say, because what we would claim here from our fieldwork and our anthropological approach is that humans are not a disturbance to technological design. They are actually part of the infrastructure and should be considered like that when you design engineering technology. So that also means that you could think how the humans are upholding robotic technological system, maintaining them, but also consider how over-promising, for instance, autonomy in robots can create a bad situation when the robots hit reality. So I don't know if you want to end with the last word.
And yes, the end, we'll say it very quickly, is designing for collaboration, and in this we mean collaboration with autonomy, of course, is safer than designing for independence where humans are not involved in the systems.
Thank you.